In problem 7, we're asked to solve the system. I notice that both the first equation, x plus 2y is equal to -1, and the second equation, 4x minus 4y is equal to 20, are in standard form. So they are set up with the x's over the x's, the y's over the y's, and the constant or the known quantity over the known quantity, which is set up for elimination. So in looking at the two variables, I could either zero pair the x by multiplying the top by -4, or I could zero pair the y, which I'll choose in this case, by multiplying the top equation by +2. If I multiply this by +2, I'll end up with +4y, and the bottom equation a -4y to zero pair the y's. So I will multiply by 2 all the way across. I'll rewrite my new equation to the right. 2 times x, 2x, plus 2 times 2y is 4y. It's equal to 2 times -1, which is -2. And I'll copy the second equation directly beneath it. 4x, -4y is equal to 20. I can now add straight down to get my zero pair. 2x and 4x is 6x. 4y and -4y is 0. 20 and -2 is 18, and divide by my my x coefficient, and quickly get the value that x is equal to 3. I'll now need to determine the value of y. I can use either equation to do that. I'm going to use the original top equation, which is x plus 2y is equal to -1. I'm going to substitute my value of x into this original equation, plugging in 3. I'm now going to solve a two-step equation by adding a -3 to both sides. Three and -3 is 0, leaving +2y. -1 and -3 is -4. I can now divide by my y coefficient of 2 and get the value that y is equal to -2. So in the top equation, -2 plus, 3 plus 2 times -2 is equal to -1. Well, 2 times -2 is -4. 3 and -4 is -1 is certainly true. I now need to check this in the second equation to make sure the math is also true. First, we're rewriting the equation. I will now write it with parentheses so I can substitute. I will now be careful to substitute the correct value in the correct place. And follow order of operations. Four times 3 is 12. -4 times -2 is +8. 12 and 8 make 20. And I get a true statement, which means that x is 3 and y is -2 also works for the second equation. So I can now make the statement that 3, -2 is the solution to the system because it's a point on both lines.